So for the next one, we have the sector of a circle of radius 3 centimeters, subtends an angle of 2.8 radians at the center. Then it says find the area of the sector of the circle. All right, so I'll give you a minute to copy that down. Okay. And the first thing we want to do when we have an example like this, where we have all words and no pictures, is draw the picture. Okay, so we have a sector of a circle of radius 3 centimeters, subtends an angle of 2.8 radians at the center. What does that mean? Anybody?
That means the sector has the central angle of 2.8 radians.
Did you say the center has an angle of 2.8 radians?
No, the sector has an angle of 2.
Okay, very good. Yes, so our circle, draw out a circle. We have a sector, and we are going to have 2.8 radians as our central angle, and the sector that they were talking about had a radius of 3 centimeters. Okay, so subtends is a fancy math word that just kind of means extends from. Like this central angle is extended from the radii coming out from the center, if that makes any sense, hopefully a little bit. Okay, and so it asks us to find the area of the sector of the circle. So area, using our formula that we've been given, is what, Worries? Worries, are you there?
Yeah, 1/2 r squared.
What's r?
Radius.
Huh?
Radius.
Say, well, did you say radius?
Radius.
It is the radius, but what is the radius for this problem? What's the value?
3.
Yeah, so 3 centimeters squared, and then times what?
The central angle, which is 28.
Not 28, 2.8.
Oh, 2.8.
Yeah, and it's in radians. Very good. Okay, and so this is going to be equal to some sort of centimeters squared. What do we get? So 9 halves times 2.8, which that end up with?
I can't do quick math.
Okay. Oh, do you have a calculator on you?
Yeah, I'm turning on my calculator. Okay. For the first part, I got 4.5.
Well, yeah. So that's 9 9 over 2. Sorry about the dog. So that times 2.8 is what, Worries?
12.6.
Yes, 12.6. Very good. So 12.6 centimeters squared is the solution for that problem. Okay, and then our last example, a sector, oh my goodness, Brooke, of radius 12 meters has an area of 100 meters squared. Hey, you gotta be quiet. And it wants us to find the central angle. Okay. So let's see who's left. Avanish, can you help me out with this one? Can you help me set up a formula for it?
Sure. So the area of a sector, the area of a sector is one half r squared theta. So this would be, and the area it's given is 100 meters squares. You said so 100 is equal to 1/2 times 12 squared, which is 144, and then times theta because we're solving for theta.
Very good.
And then we so 12 squared is 144, and half that is 72, so 72 theta. And then we divide both sides by 72 to find theta. And we get 100 over 72, which simplified would be 25 over 18.
Radians.
Radians, yeah.
All right, very good. Let's see. All right, very good. Now we are going to talk about things that IB may ask for. And I believe questions like this are on your Around the World. I haven't checked it. It's been a minute since I've checked it, since last year. But I believe that you guys have practice problems that will go over this. But we're going to talk about the general formula for each of these things. So what it may ask for, okay, and I'm going to write it out in words, is the area of the shaded, ladies, region. Okay, so we have this little shaded arc. It's like part of the arc, but it's cut off by this triangle. So what you would do to calculate the area of that region is first calculate the area of that whole sector, and then subtract off the area of the triangle that's there. So you would have 1/2 r squared theta minus 1/2 AB sine C, okay? Where A and B are sides of this triangle, and C would be the central angle of the sector. What questions do you guys have about that?
So the 1/2 AB sine C, that's basically the area of the triangle, right?
Yes, exactly. That's the area of the triangle.
Okay.
Okay, and then there are two more things that IB might ask for. One of them would be, so if I have this circle here and I have this whole sector, pretend like that vertex is in the center of the circle, it may ask for the perimeter. And that would just be R, the radius, plus another R. So R plus R plus L, which is our arc length. What questions do you have about that? Okay, they may also do something similar to the example I gave up here, but with perimeter. and cut this off and ask for the perimeter of this little kind of crescent thing right here, that shaded region. So the perimeter of the shaded region is going to be L, which is the arc length, plus this side of the triangle. And you could find that using the trig review stuff that we did at the very beginning of the week last week. Okay, so what questions do you have? That is the end of our arcs and sectors notes. Okay, so no questions? All right, so